Alright, I thought I'd do a couple examples in case you can help get started. So number one is a good place to start. Here we're doing the limit of x equals 12. But if we put in 12, our denominator is going to be 0. So this is a classic case of needing to do some algebra in order to evaluate our limit. We are going to be able to cancel that x minus 12 eventually so that we can evaluate the limit algebraically. So that's your goal. Get rid of that denominator so that you can plug in 12 and not get 0 in your denominator. Here we go. The first thing I'm going to do, just like with any other complex fraction, is I need a single fraction over a single fraction. So my numerator here is a problem, not a single fraction. My denominator is, this is x minus 12 over 1. So I need to find a common denominator in my numerator. In my numerator, I'm going to multiply my 1 over x by 12 over 12, and my 1 over 12 by x over x. So everything else is going to stay the same, and it's important that since we're doing a limit, we're going to keep writing this limit notation until we actually evaluate it. Alright, so my numerator is 12 minus x over x minus 12. Or I'm sorry, 12 minus x over, so 12 times 1 is 12, minus 1 times x is x. And my denominator isn't x minus 12, it's 12 times x. There we go. So now we have a single fraction with a common denominator over a single fraction. And now we can combine. So if you like to flip the second and multiply, you're going to be flipping that bottom fraction. If that's the tactic you like to see. So if you like to flip, this is what you're going to flip and multiply. What I like to do is group. So I like to group the top and bottom. That's going to be my numerator. And these middles are going to be the denominator of my mean fraction. So my numerator is 12 minus x times 1, which is just 12 minus x. And my denominator is 12x times x minus 12. I can almost cancel, but not quite. So my numerator is different than my denominator by a negative. And so you can take that negative out either way. I think when I did this on the work I scanned in, I kind of showed it in the denominator. You can show it in the denominator or the numerator. I kind of think I would prefer it in the numerator, but it doesn't matter. So if I take a negative out of here, that's going to make my 12 negative and my x positive. And I'm going to rewrite that. Again, I keep writing the limit notation because I haven't taken the limit yet. So that is negative 1 x minus 12 over 12x times x minus 12. And that's in a perfect form to cancel your x minus 12. Once you cancel your x minus 12, then you can plug in your 12. So now you're ready to take the limit. So now you can plug the 12 in for your 1x there. Negative 1 over 12 times 12 is negative 1 over 144. All right, I picked another problem to do as well that's just set up a tiny bit differently than that one with your fraction. Number 2 is very similar to that problem, so you should be able to bust through number 2 now. Number 3 and number 4 are very similar. Number 2, number 5. So the thing about this one is, it's a little bit different, is that we have this 1 kind of floating out here in your numerator. And when we have fractions everywhere, I like to make, for real, fractions everywhere. Again, we can't just plug in our 0 because our denominator would be 0. So I need a common denominator in my numerator to combine. And that common denominator is going to be x. So my common denominator in my numerator is x plus 1. And the top of that fraction is 1 minus, and then I have this negative 1 times x. Precision is really important here, so that's why I'm making sure that I do everything I can so that I don't make mistakes. I'm making everything to a fraction. I'm keeping that negative 1 so I'm sure to distribute it. I'm showing every step, because when we don't show every step, we do tend to make more errors. So in my numerator, I'm going to distribute that negative 1, so I have 1 minus x minus 1. And in the numerator of my numerator, those ones are going to cancel. And I'm almost ready to actually take the limit. You want to do everything you can not to make mistakes on the algebra. You want your mistakes in calculus to actually be calculus mistakes. Again, if you like to flip and multiply, you're flipping the denominator. I like to group, so that's what I'm going to show. There's my numerator. There's my denominator. I still haven't taken the limit, so I'm continuing to write that notation. So I have negative x times 1 is negative x. And in the denominator, I have x plus 1 times x. Don't multiply out unless you absolutely have to. Here my x's cancel, which is what we were working for in the beginning, from the beginning. And now, if I put 0 in, if I plug 0 in, I'm not going to get 0 in my denominator. I have negative 1 left on top, x plus 1 left in my denominator. I can plug that 0 in. And when you plug that 0 in, that's when you lose the limit notation. So negative 1 over 0 plus 1 is just negative. So there are 2 of the problems for you that you were assigned today. The algebra is pretty straightforward. Just be very careful and precise. The key is posted on Canvas, so please check your work. If you're not matching the answers that I provided to you in your packet, make sure you're checking their work and finding your mistakes. Hopefully this was helpful.